Will you succeed? Yes, you will indeed. So I want to talk about our success story, which is arson. So we were the first to apply GCxGC analysis to arson investigations in 2011. We worked with the Penn State University at the time. I've worked with the University of Alberta, and now I work with Mount Royal University and Agate. And we do GCxGC analysis for arson. And again, it was the first applied in 2011. We started to do it routinely as of 2016 and have been doing it ever since. And we've done over 150 routine wildfire investigations already, 3 trials thus far where the data has been accepted in the courtroom. That's a big thing to get something new instrumentation accepted. In the US, there's this Daubert rule that something has to be validated and proven before it can be accepted in a courtroom. So having something pushed to the courtrooms is important. And we've got 3 trials already that have accepted our data. We have better sensitivity than the method that is currently used, called the ASTM method. We can detect lower concentrations. That gives us a better capability of seeing stuff. We have more data available. I can fingerprint the gasoline, and to the point where I'm starting to look at identifying which gas station it came from. Now, it's not possible if a fire starts in a major city and there's 450 gas stations, we don't know which one it came from. But small town fires where there's only 3 gas stations or 7 gas stations, we certainly can tell where it was purchased from. And again, this is that removing the interferences that are in these analyses and allowing us to see what we need to see to be able to identify. And this is a chromatogram that we look at. These are the major peaks we look at, the 3 Musketeers and the Castle group, and I don't know why they gave them these names, the Gang of 4, but that's showing us a couple chromatograms of what the GCxGC analysis does. This is what we would have been looking at before. So here's our one-dimensional chromatography, everything's squished, where there's stuff squished together, I can't see everything, whereas this sort of makes things pop. I can see things stand out almost instantly. Gives me much better capability of identifying stuff. We work with Accelerant Canine Detection, Accelerant Detection Canines, ADCs. We brought one in with the previous Agate Tech Talks to give a bit of an example. These dogs are amazing. I was going to say flippin' amazing. They are a way of detecting stuff in the field, and nothing beats their detection limits that I know of. And there's a publication by Heronick's group at University of Alberta where they tested these dogs, and the dog was able to detect 5 picolitres of gasoline. They were unable to measure it. They actually had to just dilute it and then dilute it again, and the lab was not able to measure as much as this dog was able to see. 5 picolitres almost every time. So they're incredible detection. So this is really parts per trillion detection limits. Our standard method uses GCMS. We are only supposed to measure about 50 chemicals, not even 35 chemicals. And it's really focused, the methodology is really focused on patterns. So you're supposed to be able to see distinctive chemical patterns to say if something's there or not. And when you get a whole bunch of burnt carpet or burnt wood or muskeg or car debris or all that stuff that gets put in these debris, we get a lot of extraneous peaks and a lot of other stuff. And believe it or not, it's less than a 20% positivity rate. So if a dog says there's something there and we send it for analysis, 1 out of every 5 times the lab will say yay. And that's the only data that goes to a courtroom. You can't accept data from just a dog detection. So the lab analysis is extremely important. And so a 20% positivity, that's with routine fires. With wildfires, it's even less. So we've done some improvements on it. So this is an example, and this is in our recent publication from last year, where I'm showing you all the other stuff that's in the chromatogram is this grayed out black, right? Or grayed triangles. The compounds we look for are in blue, and the known natural chemicals that are naturally present in wildfire are in green. And those are just a few of them. We didn't do a very comprehensive search, just to give you an example. And if you can imagine this, if I squish this all to one side, all of these things sort of are on top of each other, right? So it was only the GCxGC that allowed us to separate them out from each other to be able to see the ignitable liquid residues, these chemical peaks that we're supposed to be finding. It was only the GCxGC that allowed us to do that. And some examples, this is actually residential fire that we were looking at. But we get these huge peaks like acetophenone and benzaldehyde, and they're in almost percentage quantities. There's these gargantuan things that just kind of screw up the whole detector and mask. And to be able to identify a gasoline, I have to be able to see the Castle group. And with that big blob coming right here, you can't see this peak, and I can't identify it as positive. And I know there's an interference there. I can see there's an interference there, but I still can't call it positive because I don't get that peak matching or that pattern matching that I need to look for. So this is how we improved it. In 2015, we had 80 dog hits submitted, so we're going to assume the dog was right because they can go to 5 picolitres for crying out loud. And the lab, that lab hit, I should have changed that, that's wrong. We got a 63% detection rate. That doesn't make sense at all, so just ignore that top line. 2016, we had 558 samples where the dog said, there's stuff here. We measured it, we got 141, so that's about a 24%. So I'm doing better than most. Just remember, it's only 20% positivity. I said wildfires was worse. These are all wildfires, and I got 24%. So I, pat on the back, I'm 5% above average, but I'm still at 25%. That was also the year we instituted GCxGC analysis. So of those 558, 189 got sent to GCxGC, 130 of them came back positive, so I instantly went up to almost 69%. That was pretty good. Over the years, we've improved our method, and the field team has also improved how they collect samples, where they collect samples. We've done some education on that side of things, and they're great at sampling. But right now, in 2019, I haven't done it for 2020 yet, it was a slow year. 132 samples submitted, 106 were positive, so I'm just over 80%. So I'm starting to feel like my grades at school are acceptable. I never got 80%, especially not in university, but that's acceptable to me. So if you're going to spend money, you'd rather have 80% of your samples come back with the right answer rather than 25%. And that's the way the fire investigators were looking at it. They'd send samples, they'd smell like gasoline, and they'd get the results back. They're like, non-detect? What do you mean non-detect? I could smell it. This is why. These interferences caused huge issues.